Hey everybody, today I'm going to be showing y'all how I made this little product. I call it the Domp Truk. Let's get started. Alright, so here's the finished model of the Domp Truk. If you're curious about how you spell that, I actually made a tag for it here on the back. So D-O-M-P T-R-U-K. That is not how you spell dump or truck, but that's what we're going with. So I want to just step y'all through how I made this, and this is just going to be a broad level overview, nothing too crazy, but I just thought that it'd be interesting for you if you're curious or learning CAD for the first time. This will be a just quick overview of my thoughts about how I do things. So started off with this rectangle. Obviously it's quite different from what you just saw, but everything complex kind of starts with these basic couple of shapes that we use in CAD. So this is actually 200 millimeters here. And the reason I did that was because I felt like most 3D printers have a print bed that's a little bit over 200 millimeters. Just in general, like the PRUSA Mark III, the Ender series, the Bamboo series, etc., etc. 200 is a pretty good size that most people can print, for the most part at least. So start out this rectangle, and this is kind of the main like body portion of the truck, and obviously this is about to be the axles of the truck. So made that, and then we're going to kind of progress on a little bit. Just made a kind of a rough axle initially, and then started to work on the wheel and did some circular patterns for that, for the treads. And then you can see there I also made, this is actually also a circular pattern. I'll just briefly show that real quick. So I just projected this circle, made the chamfer first, and then projected the circle from here to this area, which I think is 1 or 2 millimeters, and then after that just extrude, straight off a couple millimeters, and then you add the chamfer to that, and that's how I ended up with this thread shape. And then obviously just pattern it around and then do a mirror across the midline to get this other side. So again, symmetry is really your best friend when you're doing CAD. So a wheel obviously is pretty symmetric, and even this part, the origin is actually right here. So once I get done with this axle, all I have to do is mirror this, and now I have the back axle ready to go for the most part. So then just going to progress along, just making some of the connection points here, and then now I'm working on the rim of the wheel. Continue through that, and then again I'm going to use a circular pattern. Go here, pattern, circular pattern, and then you revolve around that axis. So that's what I'm about to do here. And so made the rim there, and I was actually referencing an actual Tonka truck for this. I didn't come up with this all by myself, but I think it's still good practice to be able to try to use a reference and recreate it. So ended up actually just splitting this and reducing the size because I felt like it's a little bit too large. And actually the reason I did that was because initially I decided, okay, I'll split this in half, I'll make the thread here, and then I'll mirror that and have the mirrored thread on the other side. And originally that's what I did. So I had just a mirrored thread, but the issue with that is it's actually now, instead of being a right-handed thread, it's a left-handed thread because I mirrored it. And the reason that's an issue is when you tighten these wheels, so most people, you'd hold this in one hand, this in the other hand, and kind of twist it to tighten it down. The problem with that is you figure out really quickly that one is tightening and one is loosening, so you're kind of in a never-ending cycle of trying to tighten one without loosening the other. So they both need to be right-handed is what I'm trying to say. Now I'm starting to work on the bed a little bit, so this was the original sketch for the bed, and initially I actually didn't constrain it. So that's another thing, that if you're just getting started out, so since these are all black, that means it's all constrained. That means that I've dimensionally defined everything in relation to a fixed point. So I basically just use this origin point as my center point for everything. And that way I can say, okay, this point is 34 millimeters away, and then kind of build off of that, since it's kind of floating in space and it's not really directly related to these other parts. There's a bunch of different ways to do that, but that's how I did it. And what I originally did though is I didn't have all of these different angles, so I basically just left it unconstrained in some areas, so that, say I wanted to like try a little bit different size, you can still extrude it without having everything fully defined. Say I wanted to make this part wider, well, you can just sit there and mess with it, you know, in the three-dimensional space. We can try that and see, okay, let's just exaggerate things and see what happens here. Let's go to the next. So you see, like, obviously that's not really what we want. So you can actually just adjust these within the CAD, which is something that sometimes I forget about. So as long as you don't dimensionally constrain it, you can kind of play around and see what looks good to your eye. And that's something to consider when you're trying to make something that doesn't have to be dimensionally sized appropriately. You can kind of leave some of this unconstrained initially, and then go back, you know, after the fact. So now you can go back here, edit sketch, and you can say, okay, well, click dimension, which is D, and then say, oops, so dimension, and say, okay, that's around 17 or 18, so I'm just gonna make it 18. So now this is fixed, and you can adjust it, you know, however you want to after that. But you can go back and undo it, take it back to what I had it, which was, I think, was 13. But that's just a tip when you're trying to make stuff that you're just trying to make it look cool, and you don't want to just be tied to a certain dimension initially. You can draw it and not make all the dimensions, and kind of drag it around and see what you like as far as the body extrusion goes. So moving on through, so this was just a shell command. I know that seems kind of strange, but you can shell all these sides, and then you get this cutout shape there. And then again, this is so now I decided to work on the toolbox. It's kind of a simple thing to do really quick. Made that where that was just press fit. So on the other side, you can see that you just kind of print out just a little stick looking thing, and then press those together in there. So now, okay, so now this is the, I guess, somewhat interesting part about it, is the way I attached the bed to the axle. So what I did here, not saying that this is the best way to do it, it's just the way I thought about doing it, was I made kind of a plate system. So let's see. The idea for this is that it can rotate around the axle, so the dump bed obviously can dump. And what I wanted to do is make it where again, I didn't want to have support. So that's my pet peeve, is making supports where you don't really need them. So the first time I did this, actually, it didn't work very well, because I made this a little bit too narrow, and I didn't have this little connecting piece, which I said was the tag, but it actually serves a purpose as a piece to kind of connect everything there at the back, which I think I did that a little later on. But the issue initially was, so there wasn't anything here. This was just a plate, kind of, if you imagine this portion kind of removed, it was basically just a flat plate like this straight across. And what was happening was the force from this being stuck in here is bowing a little bit this way, and then this bowed out some as a result, and then it contacted the wheels, so there was friction there, and it just didn't, the wheels wouldn't roll very good, because this was acting kind of like a disc brake pushing on the wheel. So if you imagine this bowing out, it was pressing on the side of the wheel there and causing some issues. So ended up changing that design. That's why I made this kind of square thing, is I felt like that would kind of pull everything together and keep these mostly straight, and it seemed to work pretty well. All right, so as far as the top portion, the idea here was, again, to avoid supports and trying to lock these in a way that looks good. So I cut out this bed, and I knew that I was going to split this in half because I knew it's a big part, and there's really no way unless you split it in half and then print it on this side and this side to print this in one piece. One, because it's too big, but also just because there's a lot of overhang. So if you printed it with this on the print bed, then you have to do some supports here. If you printed it this way as one piece, then you have to do supports for this. So, and this obviously. So I felt like the best way to do it, split it in half, and you can print this side and then this side, and then you're off to the races. So the only issue with that is I needed to figure out a way that they both provided something to rotate around and then also join these together. So I came up with this method. It's essentially a slot. So if you look at the side profile here, what I'm going to do is I'll make this plate that slides in, and that holds this in position. So it's supported on the bottom here, so it can't go up anymore. But it's also kind of locked in position because of this cutout that it's sitting in. So I felt like that was a good solution as far as how to do that. And see, I have that part here, so you can see that. I'll just isolate that real quick. So this is that part that I was talking about where it slots in, and actually cut this off at some point. I didn't do a great extrusion, so I ended up cutting that off, but that's in another step. But anyway, this is where this slots in. So you can see that that's where it all connects in with each other. And I'm going to unisolate that. And then if I do a quick analysis, so now you can see kind of the cut through version of it. And so again, this is that piece that holds the bed in place and that the bed rotates around. And then this is how it slots into place with this part. So I thought that was a good solution for that. I felt like it worked out pretty well, and it is a little bit challenging to get on just because it's a kind of finicky area there, but I think that it was a good solution and relatively easy to navigate. So then I made the grill. Again, this is just a bunch of patterning, and I was also referencing the Tonka toy that I mentioned a couple times. And not a whole lot to see there. I guess one thing to mention here, I'm actually just going to run through all these. So this is pretty similar, is that I just made the patterns, and this is actually not a Tonka thing down here. This is my own design, which I think looks kind of cool. So I knew I was going to print this with this on the plate of the printer. So when I was designing this part, I knew I didn't need to make some type of slide mechanism, and so here's the sliding mechanism. And if I remove the grill, you can see that if I printed this with this on the bottom, so it would be oriented like that, you again could print this pretty easily, but you need to add a chamfer here so that you don't have to have support. So that's just something I want to ingrain as much as I can. If you're getting into 3D printing, always consider how you're going to print it, so because that can really make or break you a lot. And I don't think I mentioned this before, but I was considering that also with this. So these are a lot nicer when you print it on the side, because the layer lines just do a lot better when this is in the XY direction versus the Z direction. So if you print it, you know, like that, you're going to have the layers running the long, you know, this way. But if you print it like this, then the layers, you know, obviously go up, which is preferred. So long story short, consider how you're orienting things, and then for this you can chamfer it. Pretty easy to do. I think I'll do that later on here, but that is really helpful if you're trying to make something easily 3D printable. So there it is. You can see that if you printed it this way going up, and then that is no issue instead of a 90-degree overhang. And so now just want to kind of skip ahead a little bit. Okay, and there's the tag that I was talking about, and the point of that is you can see if I select it, it just goes in those two holes and adds some additional support and kind of clamps it all together so that these don't try to kind of splay out and that everything just kind of stays in the right position. Another thing I added was this chamfer here, and so now the plate kind of sits under this, because before I actually didn't have that and the plate was kind of trying to bow up a little bit, so that's a way to kind of mitigate that deformation there. So felt like this turned out relatively well. I'm sure there's a lot of different ways you could do it and someone might have a better way, but I think that pretty happy with the results I got. And then this was kind of a late addition. So if you look at most trucks, they have these little cutouts. They don't have the black portion though. So most of them actually look like that. I thought it was just kind of a cool effect to add to it, but I ended up didn't really like how this printed off. So it basically does this as an overhang, and the overhangs I printed were okay, but they weren't really cool looking. So thought I could just add these little slits, and they basically just press into place. And at the end I'm going to show you all how I print those, because it has a infill pattern instead of being solid. So let's see here, I think I'm basically done at this point. The cab was pretty straightforward, just made a little cutout rectangle, and then I didn't want to have to do any support, so the way I navigated that was just made a ceiling for it, and those have little holes on them, so you just kind of snap that down, and mine snapped into place pretty well, so thought that worked out decently. And then this is obviously the exhaust pipe. Every big truck needs an exhaust pipe or smokestack, so just kind of made a cutout for that. Pretty straightforward. So that's the finished model. I did skip over certain parts because didn't want to bore anybody, but also made the joints where this actually rotates like it's supposed to, and then these rotate kind of together and these rotate together. So I thought that was pretty cool to be able to demonstrate that. So that's it. I think that's a pretty good overview of my thought process. Again, the point was really to try to make this pretty easily 3D printable. That's why some of the design decisions were made. One thing I also didn't showcase was I added these stick pieces here to kind of make everything tight up at the top, and those just kind of press into place. So I think that overall I'm pretty happy with it. It turned out well, I think, and I would be happy if I gave this video a thumbs up, because it did take me a little bit of time to put it together, and hope that you like the model. If you decide to print it off and do a different color, let me know. I did want to show you how I made these slits, so let's jump into PRUSA Slicer and I'll show you how to do that. So now I just imported the slat.stl file into PRUSA Slicer, and I wanted to show you all how I got the pattern that I got with the print. So if you click on it, you go up here and right click here, and then you go down to infill and just click on that, and then you'll see this little box come up down here. But we actually want to do that same thing again, right click, and then go to layers and perimeters. So now we have these two changes that we can make to the slicer for this individual model. And if you're printing something else with this, you can still do this just for this part. And if you have copies of it, so I'll show that now, this will apply to all the copies, but if you have a different model, then this won't apply to those. So instead of changing the global settings of the whole slicer, you're just changing the settings for these individual parts. So what we want to do is you want to go into here, into the part name file. We don't want to go in the instances. And then we want to go down here to bottom and change this to 0. So right now there's 3 solid layers on the bottom. We're changing that to 0. And then on the top there's 4 solid layers by default. So we're changing that also to 0. So if we just slice this, you'll see that pretty empty looking, but obviously that's different than what we had initially. There's no top or bottom. And if we just change this to like 30 or 40, let's try 40. So now that looks a lot more like what we were going for. But what I use usually for this pattern is the honeycomb pattern instead of the grid. So right now we're looking at the grid. So you change to honeycomb and then slice it again. So I like how that turns out. So the last thing I like to do is to change the perimeter value. So right now we have 2 perimeters. You can see the orange and kind of yellow looking lines there. So those are the 2 perimeters. And I think that for the parts that don't have a top or bottom, it's good to add a couple perimeters just on top of that. So I usually change mine to 4. And then we'll re-slice everything. And you can see that now there's 4 perimeters. So to me, I think this is a pretty good setting to try it on. 40%, you can do 50%. You know, I don't think 15% looks as good, so you can look at that. I mean, it's okay, but I like it around 30 or 40 usually. So let's try 40 again. So that looks pretty good to me. And again, this is just a way to kind of make it look different. Some people might like the solid, but I think it looks nice with this honeycomb pattern. So just wanted to explain how to do that real quick. There's actually a PRUSA video on how to do it. That's how I learned, so I'll link that down in the description below. Alright, so that's about it for this print. I really enjoyed making this and putting it together. I feel like it came out pretty good. I used to play with a lot of trucks like this when I was young and spent a lot of hours with them. Thought it was fun then and still kind of fun now to make my own. So hope that you enjoy it, and if you print one off, make sure to tag me. I'd love to see it printed off in different colors. I think it'd look really cool in a lot of different combinations of colors, so don't forget to do that. And if you haven't done so yet, don't forget to subscribe to the channel. Thank you so much. Have a good one.